So just since finishing the last video, I've added in a couple of quick questions here, just to go over this idea of the 68, 95, 99.7% rule. So calculate the probability that x is between 30 and 35. Well, looking at the graph here, here's 30 the mean, and here's 35, which is one standard deviation above the mean. So what we're actually looking for is that area right there. And as we can see over here, we have 68% of the scores are within one standard deviation of the mean. Now, that's out both sides of the curve, and because the curve is symmetrical, that means we're only going to have half of that, because we've only got this side right here. So I can just straight away say that, well, that's going to be equal to 0.34. So half of that 68% is 34%. Secondly, calculate the probability that z is greater than 2. So, looking at my z distribution, here's 2 here. So I'm looking for the part where z is greater than that. So all that section out there going on forever. Well, I'm going to use the fact that I know that 2 standard deviations will give 95% of all scores. That means that there's 5% left over. So I'll have 2.5% out this end and 2.5% out the other end. And as you can see, I've just answered that. We know that it's going to be 2.5% of all the scores which are greater than 2 in the z distribution. So that part is going to be equal to 0.025. Now, I should also mention that these are just approximations, but they're pretty good approximations. So, we use them fairly regularly and don't often need a high degree of accuracy, though if you use the calculator to figure it out, it will give that higher degree of accuracy and might help if you need an answer to like 4 decimal places or something like that. So this one here, calculate and comment on the z-score for an actual value of 22 in the above distribution. So I'm going to calculate the z-score. We're talking about an actual score of 22, which is about here. So we can straight away see that's a fair bit below the average, but that's alright. So let's go z equals x minus mu divided by sigma. That is 22 minus 30 divided by sigma, which was 5. So 22 minus 30 is going to be negative 8 divided by 5, and that is negative 1.6. So therefore the score is 1.6 standard deviations below the mean. And that's all that you would be expected to do in a question like that. But it's just a matter of remembering that when we are talking about z, we're talking about how many standard deviations we are from the mean. So again, that negative score means that it's below the mean. The last thing I'm going to do in this video on the normal distribution is just to highlight this question right here from the 2015 VCA Math Methods exam, so fairly recent one. But this is a really good question that I would strongly encourage you to have a go at doing, because this is really just using the symmetry of the graph to sort of figure out these different probabilities. So I would suggest that you after watching this video, go and have a go at this question. Otherwise, I think I should also mention that you can get the answers on the VCA website as well. So, have a go at it for yourself, but then check it as well and see how you've gone. Right, I'm going to leave the video there, and we will see you next time.